So 7.2 is almost identical to 7.1. We're still going to be finding confidence intervals for the mean. And so everything will look the same. You're going to have your answer in an inequality, and then you're going to have to write it out and all of that sort of stuff. But here's the difference, and this is going to happen in Chapter 7, Chapter 8, and Chapter 9. So we're going to learn to do something one way when sigma is known. That's what 7.1 was. But now we're going to do it when sigma is unknown. So remember, this is the population standard deviation. It's pretty unlikely that you know the population standard deviation. So even though we do the problems like we did in 7.1, more than likely we're going to have to do 7.2 problems if we ever do this, if we ever do actual statistics in the real world. It's very unlikely that you would know what the standard deviation of the population is. All right, so what we have to do is we have to use a different chart. So now you're going to have to know the difference whether you should use the Z chart or the T chart. Obviously, when you're doing your homework and that sort of thing, it's going to be easy because you're going to know if it's 7.1 or 7.2. But when you get to the Chapter 6 and 7 test, that's where you're going to have to really know whether you use the Z chart or the T chart. Okay? The only time we're going to use the T chart is when we are doing a confidence interval when sigma is unknown. Okay? So if you don't know sigma, which again is population standard deviation, you're going to need to use the T distribution. You will know the sample standard deviation. And that's just S. Okay, so that's still going to say standard deviation in the problem, but it won't say population standard deviation. That's how you know whether you need to use the Z chart or the T chart. Okay, one thing when we look at the T chart, and I will be honest, the T chart is way easier to use. So you guys are actually going to be excited to use this. Maybe not excited, but you'll like it a little bit better. Okay. So there's a big spot for this and we don't need to use it, but the degrees of freedom, this is something we have to use on our T chart, is going to be n minus 1, where n is your sample size, remember. Okay, so we'll keep that in mind when we move on to the bottom here. So here's the formula for the confidence interval, and you're going to see how similar this looks to 7.1. X bar minus T of alpha over 2 S over the square root of n, less than mu, less than x bar plus t, alpha over 2, S over the square root of n. Okay, or again, if you don't want to write the whole thing out, x bar plus minus t of alpha over 2, S over the square root of n. So there's only two things that are different. In 7.1, this was a Z rather than a T, and this was a sigma rather than an S. Okay, other than that, it looks the exact same. So we have to use the T chart rather than the Z chart, and we'll be using sample standard deviation rather than population. So here's how you're going to use this lovely chart. Look at the very bottom. Confidence level, percents. You don't have to draw a picture. You don't have to cut things in half. You don't have to do any of that. You literally just look along the bottom. And then along the side, it says DF. That's your degrees of freedom. So this chart is way easier to use. Okay, so for here, find the T of alpha over 2 value of a 95% confidence interval where the sample size is 22. So that means your degrees of freedom is 21. So 95%, degrees of freedom 21. So along the bottom, 95%. Along the side, 21. 95%, 21. 2.080. That's simple. No drawing the chart, like I said, no having to think of alpha over 2, any of that stuff. So even though it says T of alpha over 2, you don't even have to worry about what that means. You just use the chart. Okay, next one. T of alpha over 2 value for a 98% confidence interval when the sample size is 15. So that means our degrees of freedom is 14. Don't feel like you have to write that down all the time. Only if you think you need to. Alpha over 2. So 98% right here, all the way up to 14, 2.624. That's it. That's the only difference, is that you're going to use that chart instead of the z-chart. So most people say, can't we just always use this one? Well, the problem with this one is it's less accurate. Okay, the z-chart is the most accurate one, but if we don't know the population standard deviation, which is likely, then we have to use this t-chart instead. Okay, so that's why we have to use it. So 10 randomly selected people, so n is 10, which means your degrees of freedom is 9. Okay, again, up to you whether you write that stuff down or not. How long they slept at night, the mean time was 7.1 hours. Standard deviation was 0.78. So again, we know this is 7.2 because it's in our notes, but the way you will know when you're just doing them, there's no population in here. It doesn't say sample, it doesn't have to. It would have to say population standard deviation in order to use the one from 7.1. Okay, so that's how I know it's S. Find the 95% confidence interval. So I need to do T of alpha over 2. 95% degrees of freedom of 9. 95% all the way up to 9, 2262. 2.262. Okay, other than that, it's the same. 7.1 minus 2.262 times 0.78 over the square root of 10 less than mu less than 7.1 plus 2.262 0.78 over the square root of 10. Okay. Again, if you want to do plus minus instead, that's fine. I just want to have it all written out. Again, 7.1 minus 2.262 times 0.78 divided by the square root of 10. 6.5 is less than mu, which is less than, again, second enter. Go back and change that minus sign to a plus sign. 7.7. Okay, so here's the first part of your answer. Then we needed to write. You can be 95% confident that the mean number of hours of sleep is between. So some people would probably leave it as 6.5. I'm just going to say 6 and 8 since we are rounding anyway. Okay. Again, obviously some people sleep more than that. Some people sleep less than that. But if you could actually get the population of everybody, or again, it depends who your population is. But keep in mind this was only 10 people. So we're making a very bold statement based on only 10 people. But again, that's what you do in statistics, is you take the information that you have and you apply it to whatever the situation. Okay. This last one I'm going to do on its own video, just because there's going to be a lot of calculator work I have to show you.